Example 13. We're looking to evaluate each of the following definite integrals. Part A asks us to find the integral of x squared dx between the lower limit of 2 and the upper limit of 3. So our first step when doing this is to integrate. So we raise the power by 1 and divide by that power. So we're going to divide by 3 of x cubed, close the square bracket and put in our upper and our lower limits. Our next step is to substitute in our upper limit and our lower limit. So we're going to get 1/3 3 cubed, and we're going to minus from that 1/3 2 cubed. We then just simplify this. So 3 cubed is 27, so 27 on 3. Minus 2 cubed is 8, so minus 8 on 3. Simplifying that just one step, and we're going to get 19 on 3 as our end answer. In example B, we're looking at finding the definite integral of x squared between a lower limit of 3 and an upper limit of 2. Having a larger number on the bottom as our lower limit, and 2 on the top as our upper limit, should produce something interesting. The curve x squared is something that's totally above the x-axis. So if we were having 2 to 3, we should get a positive number. In fact, we just did that in part A. But as we're now going between 3 and 2, I'd expect to get a negative number out. Let's see what happens. So first step again is to do the integral. So the integral of x squared is 1/3 x cubed. And we're still looking to put that between our upper limit of 2 and our lower limit of 3. Substituting in 2, so 1/3 2 cubed. And then we're going to minus 1/3 3 cubed. So same numbers as our part A question. Except this time, instead of having 27 on 3 minus 8 on 3, we're going to have 8 on 3 minus 27 on 3, resulting in negative 19 on 3. So by switching that 2 and 3, our limits, we've actually just got the same area as what we got in part A. We've now just made it negative. And if you looked at the properties for definite integrals, you'll note that the last one says that if we switch 3 and 2, or our upper and lower limits, then all we need to do is put a negative out the front, which is exactly what we've just done here. Alright, part C, we're looking to do the integral of x to the power of a half plus x to the power of 3 halves between the lower limit of 0 and the upper limit of 1. First step, let's do our integration. We can do each of these terms integrated separately. So raise the power, we get 3 halves, and we divide by that new power of 3 halves. Raise the power and we get 5 halves, divide by 5 halves. And then we still have our lower and upper limits of 0 and 1 respectively. Now this is not nice. You could technically, because we're just after an area, you could do a straight substitution at this point. So you can substitute 1 in here, 1 in here, minus 0 in here, 0 in here. That would work. You could do that. I'm going to choose to simplify this a bit more first. So we're going to go through and flip change those fractions. So we get x to the power of 3 halves with 2/3 as the fraction, and then 2x to the power of 5 halves with 5 on the bottom of the fraction. Still between 1 and 0. Substituting in 1 and 0, so we get 2/3 as 1 to the power of anything is just going to give us 1. So 2/3 plus 2/5. In a bracket, minus 0. 0 to the power of anything is 0. So when we substitute in this lower limit, actually this entire thing goes to 0. So that's quite nice for us. We're going to simplify that just a step further. So we'll go common denominator of 15. And then add it together to get 16 out of 15 as our area.